In this video, I want to see if I can clear up some of the smoke around these really large numbers and small numbers, and how we can get them in our calculator and so forth to do calculations. Because in science and engineering, we're dealing with both really large numbers and small numbers, and typing them in a calculator like this large number I have up here with all the zeros would be tedious at best. I have a decimal number up here that's up to 1 trillion, and decimal portion of it goes down to 1 trillionth. I have put the ones digit in place of a 0 to show the demarcation as to where the names come in of trillion, billion, million, or 1,000. Because sometimes it's hard to spot when you get a group of zeros. The International System of Units organization has put out standards for the naming of things and what they mean, and that document is a PDF document, and you'll find a link to it below the link to this video. The first it's split in half. The first half is the French translation, and the second half is the English translation. All right, and if you're an engineer, you probably already recognize these powers of 10 as being engineering notation, since the exponent is a multiple or divisible of 3. That's what makes it engineering notation. These occur so often that they have these names of kilo, mega, giga, tera, and milli, micro, nano, and pico. The other notation that we need to deal with is scientific notation. And I say that because any scientific calculator, well, most of the current scientific calculators anyway, will automatically shift into scientific notation if the number is small enough or big enough. So if I just arbitrarily type in kind of a large value here, notice that the calculator has turned it into scientific notation. Scientific notation puts one number in front of the decimal point. Assume I want to write 1,234 in scientific notation. It would be 1.234, but this is 1.2 and change, so I need to make it times a power of 10 to get it back up to 1,000, and that's going to be to the third power. It's simply taking the decimal point where it was and moving it back until there's one digit in front of it. And you do that to any number and then multiply it times the appropriate power of 10. Okay. You can actually do work with scientific notation on a calculator, scientific calculator. Most of them have a times 10 raised to the x. So you could actually enter it in. I'm not going to do that just for the sake of the length of the video here. But put your numbers that are in scientific notation that you're going to add, subtract, multiply, or divide, put them in parentheses. I know this calculator gets confused if I don't. All right, so the other thing is this engineering notation, and we're going to do an example of how to use this. There is on most of these calculators a key marked either EE or like this one, ENG for engineering. If I click that button, it will convert my number to the appropriate power of 10 that's in engineering notation. In other words, it's multiple or divisible by 3, the exponent. Okay, so that's kind of a handy key. I think if I press it again, it does it. Yeah, see, it went down to the next one. So it just does it by rearranging the decimal point to the appropriate power of 3 factor. Okay, so It would be tedious using scientific notation to enter stuff, but we can shortcut that and make it a little easier by using another key on all of these scientific calculators, and that is the X to an arbitrary power key. And some calculators, that could be the Y to the X key. On Casios and similar calculators, it's just an empty box or whatever, or maybe a small n or something. I know on the older TI, they don't have a key like that. They use the caret, the up arrow key. So if I wanted to raise 6 to the third power, the keys I would poke would be the, well, let's do the 3 to the 6th power, since I wrote 3 instead of 6. Then press the up arrow key and the 6, and that's the same as 3 raised to the 6th power. The other thing I want to mention while we're entering in things, you'll notice that we have negative exponents here. To make an exponent negative, make sure you're using the negation key here and not the subtraction key. Now, what are negative exponents? What do they mean? If you are really fuzzy about it, you might want to look at the Laws of Exponents video. But just as a real quick refresher, all the negative means is that this number is in a denominator and raised to that power. So 10 to the negative 3 is the same as 1 over 10 to the third. Oftentimes the exponential notation is preferable as opposed to the fractional notation because it's a lot easier to see and use the laws of exponents if it's in exponential notation. All right, let's do a live example. Let's say that I have a 5 microhenry inductor, and I have 100 picofarad capacitor. Okay, so this is the inductor, this is the capacitor. And there is a formula for determining what the resonant frequency would be for these two values. So that could be handy, especially in amateur radio. So to write this 5 microhenries, that's going to be 5 times 10, and this is micro, so that's going to be minus 6. And this is going to be 100 times 10 raised to the minus 12. So let's see how we would enter that in the calculator. And I'm going to clear it just so we have a nice clean display up here. So let's do 1 divided by, and I'm going to work on this. Oh, I forgot to write the formula. That's a resonant frequency is equal to 1 over 2 pi times the square root of LC. Okay, so this is what we're going to enter in our calculator. So here's the 1 over part, and I'm going to put this denominator in parentheses. So that's going to be 2 times, and there's actually a key for the pi, so I don't have to type it in, times the square root of these values, and I'm going to enter them in just like this. So 5 times 10, and I'm going to use that x to the arbitrary exponent key and type in a negative 6. Notice that the cursor stays up here. I need to get it back down on the main line here. So I'll do the right arrow key for the cursor key here. Now I can do the times and enter in the capacitor value. So that's going to be 100 times 10 raised to the negative 12 power. And we see then that the resonant frequency of this is equal to 7,117,000 and change hertz, or 7.1 megahertz. So we're about 7.11. Let's just round that last 7 up to an 8, and that's megahertz. So that's right smack pretty much in the middle of the 40 meter band is where these two components would be resonant. Okay, so this just takes a lot of practice. Hopefully this clears it up a little bit and saves you from having to type in these really big numbers or really tiny numbers with all the leading or trailing zeros. Use the powers of 10 and this x to the arbitrary power, or y to the x, whatever key you have on your calculator. And don't forget that document from the International System of Units is linked, so you might want to read through that. All right, have fun.